Whenever the change in independent variable is very small, very small, as you please, then what will be the nature or change of variable of y? Suppose x0 is the initial value of x, of the independent variable x, and x1 is the final value. So this change we may write delta x equal to x1 minus x0. This is called increment in x. It may be positive or negative. Suppose for this change of x, y also changes as delta y equals to y plus delta y minus y. We know y equals to fx. So delta y means y plus delta y minus y, that is fx plus delta x minus fx. Here we see y plus delta y means fx plus delta x. When x changes, an increment is made, then there is an increment in y also. So what we get? Delta y means this. Now let us see what is the ratio delta y by delta x. It is also called increment ratio. What will be the value of this whenever delta x tends to 0? If this ratio gives a finite definite value, suppose it gives a finite definite value as x tends to 0, then this limiting value is called derivative of the function fx, y equal to fx, or differential coefficient of the function fx, and written as dy dx equals to limit x tends to 0 delta y by delta x. Sometimes we write delta x equals to h, similarly delta y equal to k. It may require in mathematical calculation. So it can be written as limit fx plus delta x minus fx by delta x. Delta x tends to 0. Here is delta x tends to 0. So if we put delta x equal to h, what we will get? This equals to limit h tends to 0 fx plus h minus fx by h. Mathematically we can write this dy dx equals to f dash x or y dash or y1 or dy, whatever you like. We will get f dash x equals to limit h tends to 0 fx plus h minus fx by h. This is called the derivative of fx with respect to x. Students, we have learned what is derivative or differential coefficient of a function. Now let us learn what is differentiation. Differentiation is a process in which we get the derivative of a function. Suppose c is an interior point in the interval. So what is f dash c? It is, we can write h tends to 0, f of c plus h minus fc by h. So at the point of c, the differential coefficient of y equals to fx of the function is f dash c equals to this, or it is also written as dy dx x equal to c. It is also written in this way, but this notation is commonly used. Now this definition is called, this definition of getting derivative of fx at x equal to c is called differentiation from definition, or it is also called differentiation from the first principle. Now let us see some example. Let y equal to fx equal to k say, k be a constant. Then what would be the value of f dash x? We know f dash x equals to h tends to 0, f of x plus h minus fx by h. Since it is a constant function, so fx plus h means k, that is h tends to 0, k minus k by h. Why it is k? A constant function, it is y equal to k always, y equal to k, or we can write y equal to fx equal to k. So fx plus h equals to k, and also this also fx equal to k. So it will be limit h tends to 0, 0 by h, that is 0. Since h tends to 0 implies that x not equals to 0, so it is equals to 0. So you get, if the function is constant, so derivative of the function is 0. Now let us learn what would be the value of c fx. Suppose y equals to c into fx, where c is equal to constant. Let us learn what is this. Let f of x, capital F of x equals to c into fx. Therefore f of x plus h equals to c into f of x plus h, and fx equals to c of fx. Therefore f dash x equals to limit h tends to 0 as per definition. You know, this is the definition. So capital F dash x equals to h tends to 0, f of x plus h minus fx by h equals to limit h tends to 0. Here see, it is c into fx plus h minus c into fx by h, that is you take c common, limit h tends to 0, c into f of x plus h minus fx by h. This can be written as c into h tends to 0 f of x plus h minus fx by h, that is c into f dash x. Because you know it, f of x plus h minus fx by h, h tends to 0 equal to f dash x, so it is c into f dash x. So you see, whenever any function is multiplied by a constant, then the derivative of the function, that is here you can also write dy dx, you can also write dy dx equals to c into f dash x. So c will be unchanged and derivative of fx will be made. Now I like to suggest you to get the value of dy dx or f dash x when y equals to e to the power x or fx equal to e to the power x, y equal to e to the power x, y equal to sin x, y equal to log x base e, y equal to log x base a. With the help of this principle I have already told. These are very simple. Similarly, you can get also x to the power n. Suppose I am doing this. Let here you see f dash x equals to limit h tends to 0 fx plus h minus fx by h equals to limit h tends to 0 x plus h whole to the power n minus x to the power n by h. Let u equals to x plus h. So as h tends to 0, u tends to x. Here you get h equal to u minus x. So you write f dash x equals to limit, here is u to the power n minus x to the power n by u minus x, where u tends to x. So what is this formula? You have learned limit of x tends to a, x to the power n minus a to the power n by x minus a equal to n into a to the power n minus 1. Apply this formula here. So you get it n into x to the power n minus 1. In other way also this problem can be solved expanding this, but I think it is the smallest method. In this technique you please solve all these problems very easily. Students, in my introduction I have already told differentiation is closely related to limit and continuity of a function. Now let us see how they are related. Since you know dy dx equals to limit delta x tends to 0 delta y by delta x. If this limit, suppose when delta x, as delta x tends to 0, what would be the value of this ratio? So the limiting value of this ratio is very much needed. Suppose this is 0, when it is 0, delta x equals to 0, then delta y also equals to 0. then clearly it is the value of this undefined. So you see, the very definition of limit, existence of limit of this ratio is very much important to get the value of dy dx. Hence, limiting value of this ratio is needed. Now let us see how derivative of a function is related to continuity. Suppose fx is differentiable at x equal to a, say at this point fx is differentiable at x equal to a, so we can write f dash a equals to limit h tends to 0 f of a plus h minus fa by h. As per definition, you know. Let us see. The function is differentiable, I have already told. That is, f dash a exists, and this is the value of this. Now let us see whether the function is continuous at x equal to a or not. Suppose what is this? Equals to, we can write h tends to 0 f of a plus h minus fa by h into h. We can multiply both numerator and denominator by h, because h not equals to 0. H tends to 0 does not imply h equal to 0. So we can write this limit h tends to 0 f of a plus h minus fa by h into limit h tends to 0 h. You can separate this. Here is f dash a and here is 0, so it is 0. This implies that limit of h tends to 0 f of a plus h equal to fa. You know, this is the very definition of continuity of a function of fx, y equal to fx at x equal to a. What does it mean? Fx is continuous at x equal to a. So what we get? The function is differentiable at x equal to a, that is f dash a exists. What does it imply? This implies that function is continuous at that point. Now let us see the converse is not true. Hi students, let us see the contrary. Suppose y equal to fx equal to mod x with the function. You know, this is mod x equal to x when x greater than 0, equal to 0 when x equal to 0, and equals to minus x when less than 0. Now let us see whether the function fx is continuous at x equal to 0 or not. So see, what is the very definition of continuity at x equal to a? Is limit h tends to 0 f of a plus h equals to fa. You have already learned this. Here a equal to 0, here limit h tends to 0 fh equal to f0. We have to find out whether these values are equal or not. Here see, this equals to limit h tends to fh. Here two cases, 1 f limit h tends to 0 plus fh equals to limit h tends to 0 plus means h greater than 0, that is h equals to 0, and limit h tends to 0 minus fh equal to limit h tends to 0. Here is minus h, because whenever h is negative, h less than minus tends to minus 0, that is h itself negative, then it is the value of minus h. Here is also 0, and f0 equals to 0. You have seen here f0 means 0. Therefore f0 plus 0 equals to f0 minus 0 equals to f0. It can be treated as f0 plus 0. It can be treated as, here you can write this as f0 minus 0. So you see all three values are equal, hence fx is continuous at x equal to 0. Now let us check whether the function is differentiable at x equal to 0 or not. Let us find the value of f dash 0. What does it mean? Limit h tends to 0, f0 plus h minus f0 by h, because f dash a equals to limit h tends to 0, fa plus h minus fa by h. Here a equal to 0, so f dash 0 means f0 plus h, that is limit h tends to 0 fh minus f0 by h. Here is also two cases, h tends to 0 plus fh minus f0 by h, and the other case is limit h tends to 0 minus fh minus f0 by h. Here you see fh, when h greater than 0, fh means h minus 0, f0 means 0. So what would be the value of the limit? Limit h tends to 0, h by h equals to limit h tends to 0, h by h equal to 1. And here is the value, limit h tends to 0 minus, whenever h less than 0, h less than 0, that is fh means minus h, so it will be minus h, minus f0 means 0 by h, so it would be minus of limit h tends to 0, h by h equals to minus 1. Therefore f dash 0 plus 0, here you can write 0 plus 0 not equals to f dash 0 minus 0. Hence, so what we can conclude? Hence fx is not differentiable at x equal to 0, that is f dash 0 does not exist. So what we see, fx is continuous at x equal to 0, but f dash 0 does not exist. This chapter is very much important for your higher studies. I once again advise you to learn differentiation properly. You must follow the chapters function, limit, continuity, and after that obviously differentiation. So in higher studies you will be strong in mathematics. Now students, I like to request you to subscribe my channel and to share my YouTube channel to your friends and associates.